Okay, in this lesson we'll be writing linear inequalities given a table, graph, or verbal description. Real quick, let's look what a linear inequality in two variables is. It is a relationship with a constant rate of change represented by a solution set denoted by the graph of a line that may or may not be included in the solution and the set of points above or below the line. That'll make a little bit more sense as we move along with some problems. Real quick, let's remember what inequality notation is. It just means that we don't have that typical equal sign only. We're going to have a couple of different ways of just setting solutions. So like the less than sign, we have the alligator mouth, how some people describe this. Of course, less than is going to look mostly like that. If we're looking at graphs, it's going to be a dashed line with shading below the graph of the line. So what that means is a dashed line, it's going to look something like a line that does this, and the shading is below the line. Greater than, the alligator mouth is open towards, once again, a dashed line, something like that, with the shading above. And we'll see some of this in the graphs in a couple of seconds. Less than or equal to, well, we have the same thing as we did before with the less than. We just now have a line underneath indicating that it is also equal to. So if you're looking at graphically, it'll be a solid line with the shading, of course, below, once again. And greater than or equal to, well, once again, since we are equal to as well, we have that line below, alligator mouth is opening towards, and once again, a solid line when graphing, and the shading will be above. Okay. For vertical lines, greater than shades the right side of the graph, and less than shades the left side of the graph. Alright, what they're pretty much talking about is when they're talking about x. So let's say x, or greater than or equal to, for example. Give it some value like 3. Then you'd have a graph that looks something like this. Sorry for the sloppiness, but just real quick, just trying to show you x, y. 3 would be about, let's go and put some things here, 1, 2, 3. So we'd have this line going up and down, a vertical line, and since x is greater than, the shading would be to the right. If we had something like x was less than, or let's just say less than -2, we'd have a graph that looks something like this. 1, 2. And once again, that's when you have x. You get these vertical lines. And since it's not equal to, we're going to have a dotted line. And since x is less than -2, the shading is to the left. Okay. Just a couple of examples real quick. Okay. Do want to look at this one real quick. If you can see here, we've got two lines with inequalities. One, of course, they're both equal to. That's hence why the lines are solid. We got a solid red line and a solid blue line. The solution that would satisfy everything would be in this area right over here, where the blue and the red interchange, or they come together, create this kind of purple region. So that's where if we had a solution, we could determine if it satisfies both. What I mean by that is, with inequalities, you have an infinite amount of solutions. It just needs to satisfy the area. So for example, 2, 2, that point. If we look at 2, 2, that would be right there. Well, it would satisfy for this blue line, because the shading he's in the blue region, but he's not in the red region, so therefore he would not satisfy the red line equation. Okay, as you can see here, he would satisfy this equation, but would not satisfy that equation right there. Let's look at 2, -2. Okay, 2, -2, 2, -2. He is in the purple region, so he does satisfy both equations. That would be a solution to both equations. Let's look at another one. 0.5, 4.1. So 0.5, that'd be between 0 and 1, and then 4.1 would be a little bit above, so it would be a point about right here. As you can see, he's in none of the shaded regions, therefore he does not satisfy anybody. 3.2 comma 4.6. Okay, let's look at that one. 3.2 would be about between 3 and 4, and then 3.2 comma 4.6. I'm sorry, make sure double check that point. 3.2 comma 4.6. Okay, 3.2 4.6 would be, in my opinion, about right there. So barely, it looks like he satisfies both equations because he is in the purple region. And etc, etc, etc. You can see that we have an infinite amount of solutions as long as we're in the purple shaded region. So, you could pick a point like 10 comma 1, and you can see that would exist right there in the purple region. And we can keep doing this forever. An infinite amount of points would work. Alright. Yeah, we're going to skip that one real quick. I do want to visit this one real quick. They want to write an inequality in two variables. Well, to write an inequality, we're going to write something like y. And we see that our line is dotted, or a dashed line. So we know we're not going to be equal to it. And then we're shaded above, so y would be greater than. Since we are shaded above the line, so y is greater than. Now we just got to find our slope because we want that form mx plus b. So y is greater than, well, let's find our slope. We need two good points to do that. So about right here and maybe right here. We can do our rise over run. We go 1 up and 2 to the right. So 1 up would be indicated with a positive 1, and 2 to the right, positive 2, x. And pretty easy to find our y-intercept. It is right here. Looks like at -3, so -3. So that's what the inequality would look like. Y is greater than, once again because we're shaded above. We are not equal to, since it's a dashed line. And our slope was 1/2 x, and then our y-intercept -3. See if they get the same thing. Yep. Y is greater than 1/2 x minus 3. Alright, just as an example. Now let's look at some problems down here. It says baseball fans can buy tickets for seats in the lower deck or upper deck of the stadium. Tickets for the lower deck cost $42 each. Ticket prices for the upper deck are 75% of the cost of tickets for the lower deck. Which inequality represents all possible combinations of x, the number of tickets for the lower deck, and y, the number of tickets for the upper deck, that someone can buy for no more than $800? Well, first and foremost, I'm going to find out what the ticket prices for the upper deck are. That guy right there is a 75%. So to find that, we'll take $42 times 0.75, and we get, 1 second, $31.50. Okay, so now we want an inequality that represents all possible combinations of x, the number of tickets for the lower deck. Alright, well, we know the lower deck is $42 each, so 42x, so $42 per each lower deck ticket, and y, the number of tickets for the upper deck that someone can buy for no more. So we also are going to add on our upper deck tickets, which we found at $31.50, so 31.5 or 31.50 y's, y representing the upper deck tickets. And we want no more, so no more. So in this part, it needs to be less than or equal to, because we want the total of our tickets to be no more, so we want this portion to be less than or equal to 800. So let's see which one kind of represents the same thing. Looks like G. G would be our answer right there. Problem with Y is saying the upper deck tickets are more expensive, and they're not. They're only 75% of the lower deck. Same problem with A.2H. And also they're saying that the price is greater than. And of course J is wrong because once again, same problem. Our tickets would cost more than. We need them to be no more, which means less than $800. Okay, less than or equal to. So G would be the correct answer choice. All right, moving along. Now the same thing, we got another word problem here. It says Maria and her brother have $25 to split and spend at the fall festival. If C represents the number of carnival rides and Z represents the number of zoo rides, which of the following inequalities represents this situation? Okay. Well, we see that carnival rides is $2. So, and C represents, okay, I'm going to go 2C for $2 times number of carnival rides. Plus, we see the zoo rides are 3, so 3Z. $3 for every zoo ride. And they only have $25 to spend, so we want this part to be less than or equal to $25. And once again, we want 2 times the amount of carnival rides plus 3 times the amount of zoo rides that we go on will be less than or equal to $25. Okay, well, let's look at our different answer choices that we got here and see which one matches up. I'm going to look at B and C first because they're more written in our version that we have here. But this one's written kind of the opposite way, where it has 2Z plus 3Z on the other side and 25 on the opposite side. But notice our problem here. They're saying that they want the carnival ride and zoo ride to be greater than or equal to, so it can't be B. Same problem we have here. It's a sign. It's written the same way we wrote, except the sign's not correct, so C cannot be correct. Alright, well, the other ones, they're moving our zoo rides or carnival rides to the other side of the equation. Well, let's look at A real quick. If I move the 3Z to the other side of the equation, I would be subtracting 3Z from both sides. Therefore, we get 2C is less than or equal to, well, if we brought these guys down, we'd get negative 3Z plus 25. Well, that's a problem because this is a positive 3Z, so he can't be correct. Let's look at the last one. It brought the carnival rides to the other side, so what that means is it's subtracted 2C and minus 2C. A couple ways we can write this. Well, that'd be 3Z less than or equal to. We brought down both terms because they're not like terms. We're just going to need to bring them down. Get minus 2Z plus 25. But you can also write that as 3Z is less than or equal to. Just move him to the other side and him. You can put the 25 in the front. Minus 2C. D does look like it, so that is correct. Okay. All right, moving on to the next one. We've got 6 data points are given in the table. Which linear inequalities in 2 variables can be used to represent the data set? Okay, this might take a little while because we need to check all these points and see if they work out. So, let's look at x minus 2y first. It's greater than negative 6. And that's option 1. Look at option 3. It's kind of the same thing, except we're equal to as well. So I'm going to write that one down. So we can kind of kill 2 birds with 1 stone quickly. Alright, so let's plug in the point negative 1 comma 1. Once again, x is negative 1 comma 1. Okay. So we're going to plug in negative 1 minus 2 times 1. And so we get negative 1 minus 2 is greater than negative 6. Negative 2 minus 1 is negative 3. It's greater than negative 6. Is negative 3 greater than negative 3 greater than negative 6? That is a true statement. And kind of the same thing we get over here. That's where I wrote it down. Negative 3 would also be greater than or equal to negative 6. Okay, so that point works out. You need to check the next point. 8 comma 6. And what we're trying to find is if any of these points fail, then our equation does not work. So we have to go through each and every one of these points, but let's go ahead and plug them in. Got 8 minus 2 times 6 for our y value is greater than negative 6. Okay, so then we have 8 minus 12 is greater than negative 6. And then 8 minus 12 is negative 4. It's greater than negative 6. And yes, negative 4 is greater than negative 6. Once again, same kind of equation on this side, so we have that greater than or equal to symbol going on. And it is true on both sides. So that point works. Let's plug in our next point. Negative 4 comma 0. So we're going to go negative 4 minus 2 times 0, plugging in for the y, is greater than negative 6. And we get negative 4. Well, negative 2 times 0 is 0, so we get minus 0. It's greater than negative 6. And of course, negative 4 minus 0 is negative 4. And yes, negative 4 is greater than negative 6. And once again, negative 4 is greater than or equal to negative 6. So that point works out. Okay, moving on to the next point. And yes, I know this is a little tedious, but it's kind of simple too. We just got to keep going, plugging through. So plug in the 6 for the x value, minus 2 times 4. Once again, I'm getting it from there. Is greater than negative 6. So we have 6 minus, well, 2 times 4 is 8. It's greater than negative 6. And of course, 6 minus 8 is negative 2. Negative 2 is greater than negative 6. That does make a true statement. Negative 2 is greater than negative 6. And negative 2 is greater than or equal to negative 6. Okay, so that works out. So far, all these points have worked out for all our equations. Okay, let's check the next one. All right, plug in that negative 8 in for the x. Minus 2 times a negative 1 is greater than negative 6. All right, so we get negative 8. Well, negative 2 times negative 1 is a positive 2. It's greater than negative 6. And then negative 8 plus 2 is negative 6. And negative 6 is not greater than negative 6. They are equal to each other. So this would fail for my first one. But looking over here, negative 6 is greater than or equal to negative 6. That is a true statement. They are equal to each other. So 3 is still working for us. I can stop checking 1 because one of the points have already failed. So he's out. So I'm going to go ahead and go down here real quick and say he's gone. Doesn't work for us. Yeah, let's check our last point now. Let's plug 3 minus 2 times 2 is greater than or equal to negative 6. So we have 3 minus 4, because 2 times 2 is 4. It's greater than or equal to negative 6. And 3 minus 4 is negative 1. And negative 1 is greater than or equal to negative 6. So that checks out as well. Okay. So we can say our equation 3 works out for us. So it checks out. Okay, looking at our next one, 2 and 4. Once again, we have the same scenario. Just one's equal to and one's not equal to. So this is pretty easy to do. Let me go ahead and do like I did for x minus 3y. X minus 3y is less than negative 3. And we have x minus 3y is less than or equal to negative 3. Alright, same thing. We've got to keep checking all the points. Let's start with the top one. We got negative 1 minus 3 times 1 is less than negative 3. So negative 1 minus 3 is less than negative 3. And negative 1 minus 3 is negative 4. And is negative 4 less than negative 3? That does make a true statement. And on this other side over here, negative 4 is less than or equal to negative 3. True statement. So far, so good. Works out. Let's check the next point. Okay, we got 8 minus 3 times 6 less than negative 3. We have 8. Well, negative 3 times 6 is a negative 18. And 8 minus 18, of course, is negative 10. And negative 10 is less than negative 3, just like negative 10 is less than or equal to negative 3. So that checks out. Once again, this is working out because this is the same thing as over here. It's just a sign difference, which makes it easier. We don't have to check 4 different equations. That would take forever. Okay, moving on to the next point. Plugging in negative 4 in for the x, so negative 4 minus 3 times 0. So we get negative 4. Well, negative 3 times 0, of course, is 0. And of course, negative 4 minus 0 is a negative 4, so it's negative 4 less than negative 3. True statement. Negative 4 less than or equal to negative 3. Once again, true statement, so that works out. Alright, plug in our next point. We've got 6 minus 3 times 4 is less than negative 3. So 6 minus, well, 3 times 4 is 12, less than negative 3. And 6 minus 12 is a negative 6. And is negative 6 less than negative 3? That does make a true statement. And negative 6, of course, is less than or equal to negative 3. So that point works out. Alright, once again, guys, we're almost there. Almost done. I know it's tedious. But just 2 more points to plug in. So when we get negative 8 minus 3 times a negative 1 is less than negative 3. So negative 8, well, negative 3 times a negative 1 is a positive 3. So plus 3. And negative 8 plus 3 is negative 5. And negative 5 is less than a negative 3. Just like negative 5 is less than or equal to a negative 3. Okay. So far, so good. We got one last point to check. Alright, so we got 3 minus 3 times 2 is less than negative 3. So 3, well, negative 3 times 2 is a negative 6. Negative 3. And 3 minus 6 is negative 3. So is negative 3 less than negative 3? No. Does not make a true statement. But negative 3 is less than or equal to negative 3. That is a true statement. So, remember, this was equation number 4. This one was 2, if I remember correctly. So let's go check down here. So 4 did not work for us. So he's out. But 2 did. So we're looking at 2 and 3 as being the right options. Alright, so F says 1 and 3. That's not correct. G says 2 and 4. That's not correct. H says 2 and 3. That is our correct answer right there. Alright, guys. Let's see. I believe we got one last problem. It is a graph. It says write the linear inequality that describes the graph below. Okay. Well, let's first notice this. We have y. Our shading is above the line. Okay. Shading above the line. So we know we are greater than. And since our line is solid, we also equal to. Okay. Let's go find our slope now. We kind of do have two good points plotted out for us already, so let's use those. We go 1, 2, 3, 4, 5, 6 down. So m equals, well, indicating rise over run. I'm going to write that down. And since we went down 6, we're going to indicate that with a negative 6 over our run. 1, 2, 3, 4, 5. Since we went right 5, we're going to say positive 5. So our slope is negative 6 over 5. Of course, x, and negative 6 over 5 is as simplified as it gets. Lastly, we need our y-intercept, which we see as, I'm going to get rid of this. 1, 2, 3, 4, 5, 6. Looks like 6. 0, 6 is a point. Of course, that's our y-intercept right there, where x is 0, our y value, so we get plus 6. So there's our equation right there. Y is greater than or equal to negative 6 over 5x plus 6. Alright guys, well that's it. Hope you learned something. See y'all soon.